Hi all, in this video we are going to learn about confusion matrix. What is confusion matrix? Confusion matrix is a table that is often used to describe the performance of a classification problem. In linear regression, we have mean squared error, root mean squared error, mean absolute error, and R squared to identify the accuracy of the model. For classification problems, that is when our data is categorical in nature, that is when we have qualitative data, we have something known as confusion matrix to identify the accuracy of the model. Now, let's deep dive into confusion matrix. Suppose we have the following problem statement. Our problem statement states that we have to identify whether a person has diabetes or not. Now, here we have actual values and we have predicted values. What does 30 imply? 30 people who actually have diabetes are predicted to have diabetes. So, our model correctly predicts for 30 people. What does 5 imply? 5 people who do not have diabetes are predicted by the model to have diabetes. What does 6 imply? 6 people who actually have diabetes are predicted to not have diabetes. 20 people who do not have diabetes are predicted to not have diabetes. Now, let's deep dive into this confusion matrix. So our 30 is our true positive, our 5 is our false positive, our 6 is our false negative, and 20 is our true negative. Remember that your positive and negative label refers to predicted outcome and your true and false labels refer to actual outcome. Over here we have two errors. We have type 1 error and we have type 2 error. The first one is type 1 error, that is 5, that is false positive. We are rejecting the null hypothesis when the hypothesis is true. The person actually does not have diabetes, but the model predicts that that person has diabetes. This is the heinous situation. Unnecessarily, this person will be administered insulin. There will be a wastage of resources. The next one is 6, that is false negative. We have type 2 error. What does that mean? Whenever the person has diabetes, the model will predict that the person does not have diabetes. So, type 2 error goes something like this. We fail to reject null hypothesis when the null hypothesis is false. Now, let's learn about metrics. The first matrix that we are going to learn is accuracy matrix. What does accuracy matrix do? It checks how often our classifier is correct. Accuracy is given by the following formula. True positive plus true negative upon true positive plus false positive plus true negative plus false negative. Now let's apply this accuracy formula onto our confusion matrix. So we get 30 plus 20 upon 30 plus 5 plus 6 plus 20 is equals to 0.81. Now let's learn about another matrix. It's the misclassification. As the name suggests, it identifies how many times our model has misclassified the person with diabetes. Misclassification is given by the following formula. FP, that is false positive plus false negative upon true positive plus false positive plus true negative plus false negative. It is nothing but 1 minus accuracy. Now let's apply this formula onto our confusion matrix. What do we get? Misclassification is equals to 5 plus 6 upon 30 plus 5 plus 20 plus 6, which is nothing but 1 minus 0.81, that is 0.19. That is 19% of the time our model misclassifies the data. That is 19% of the time the actual values and the predicted values are not going to be the same. Now let's look at another matrix. Let's look at recall. Recall matrix is also known as sensitivity matrix. It is used to take care of the false negative. In this, false negative is a very life-threatening situation. Actually, the person has diabetes, but our model predicts that the person does not have diabetes. Here, the person has to be administered insulin on an urgent basis, but they fail to administer. So, we have to reduce the false negative. What does the recall formula look like? Recall formula is true positive upon true positive plus false negative. When false negative increases, your recall falls. And when your false negative decreases, your recall increases. Now, let's apply this formula onto our confusion matrix. What do we get? We get recall is equals to 30 upon 30 plus 6 is equals to 0.8333. That is, sensitivity is 83%. Now let's learn about another matrix. Now let's learn about precision matrix. Precision matrix are used to take care of false positive. Over here, 5 is false positive. Here, there are people who actually do not have diabetes, but they are predicted to have diabetes. Here, unnecessarily insulin will be administered to them, which will be a wastage of resources. Hence, we have to reduce our false positive. Our precision matrix is given by the following formula. Precision is equals to true positive upon true positive plus false positive. Here, as false positive increases, our precision decreases. As our false positive decreases, our precision increases. Now let's apply this formula onto the confusion matrix. We get 30 upon 30 plus 5 is equals to 0.8571, 85%. Now let's learn about specificity. Specificity is calculated as the number of correct negative predictions divided by the total number of negative predictions. Specificity is true negative upon true negative plus false positive. We will apply this formula. What do we get? We get specificity is equals to 20 upon 20 plus 5 is equals to 0.8. Now let's learn about F1 score. F1 score is the harmonic mean of recall and precision. F1 score is equals to 2 times precision into recall upon precision plus recall, which is nothing but 2 into 0.85 into 0.6 upon 0.85 plus 0.6. It is 70.34%. The F1 score is 70%. Why do we use a harmonic mean and not arithmetic mean? Because if we use arithmetic mean, there is a chance that if our precision is high and recall is low, precision will compensate for the recall. But in harmonic mean, if precision is high and recall is low, the F1 score is also going to fall, unlike in arithmetic mean. I hope all the confusion metrics are clear for one and all. Thank